Okay, today we're going to do something a little bit different than we have the last couple of days. If you remember the last 2 days, we talked about two different types of angles that show up in circles. Specifically, they were the central angles and the inscribed angles, and we learned about their properties and their measurements and how they're related and all that kind of stuff. Okay, we're about to get into circles on a deeper level, and it's going to require us to have a better vocabulary for some of the stuff that's going to show up in circles than we have right now. So that's what we're going to dedicate today to. We're going to look at some new vocabulary. It's going to be some terms that you have likely never heard of before, but we will need these terms in order to do what comes kind of in the next part of the circle unit. So let's have a look. There we go. Okay. Very obviously, circles are a special kind of shape. Okay, they're unlike anything else. We've spent the vast majority of this year looking at two-dimensional polygons. And a polygon was an enclosed figure that was built entirely out of line segments. Well, it's very clear to see that a circle is an enclosed figure, but it is not built out of line segments. So it doesn't fit the typical definition for what we consider to be a polygon because it doesn't have line segments as sides. Okay, but being its own special kind of shape, it's going to come with all kinds of special vocabulary, some words we've never heard before, and so we're going to have to get a little bit of a new language going here, dealing it with circles. Okay, this is always one of the fun things that we do. Okay, let's see if we can come up with a definition for the word circle. Okay, it seems like it ought to be an easy enough chore. Circles are pretty much the first shape that you learn about when you get into pre-K. Okay, probably the first shape that people were familiar with at all. Okay, so who thinks they can do it? Who thinks they can come up with a definition for the word circle? Roundish shape, okay. And of course, the thing about definitions is that every word has to have its own definition. You have to be able to understand every word in a definition in order to understand the definition, right? Okay, so when we say a circle is a roundish shape, okay, so what's round? Okay, circular. Okay, so now we're saying a circle is round and round is a circle. Okay, sphere's three-dimensional. Okay, circle's just two-dimensional, flat. Okay. Actually proves to be a fairly difficult chore because circle is just kind of one of those words that we just understand it, right? When somebody says circle, we may not be able to slap a definition on it, but we all know what a circle is. And when somebody says a circle is round, okay? Well, again, everybody knows what round is, even if we can't slap a definition on it. So it's kind of a difficult chore. What'd you say? Diameter, yeah. And we'll get to stuff like that. Okay, and the thing that differentiates a circle from anything else that we've talked about, we've actually already mentioned at this class period. A circle's not a polygon. Okay, and a polygon is a shape that is enclosed and it's built entirely out of line segments. Well, a circle is not built out of line segments, but it's got to be built out of something, right? Okay, remember way back to the beginning, very first day in geometry, we said everything in geometry is built out of three things: points, lines, planes. Okay, well, if a circle is not built out of lines, and it's definitely not built out of planes, it's got to be built out of points. Okay, so a circle, the official definition for a circle is it is a set of all points that are equidistant from a given point. Well, equidistant, there's a word we haven't heard in a while. Okay, I think we defined it way back in the beginning, but haven't seen it much. What does equidistant mean? Okay, well, break down the word. What's the prefix equa mean? Equal, and distant, distance. Okay, equidistant means equal distances from a given point. Okay, well, if you think about what that says, the center of a circle is a given point. And if you start at that given point and you measure any direction away from that given point, and in any direction you go, you put a point, you put a point, you put a point, you put a point, and you do this an infinite number of times away from that given point, then you end up building our friend, the circle. And as we've said a few times already this year, circles are named after their center points. Okay. All right, the first type of structure that we're going to get to is what we call a chord. Okay. Okay. Chord, C-H-O-R-D. And specifically, a chord is a line segment in a circle, and it has its endpoints on the circle. And I'm providing you with a diagram of one, obviously. A line segment that has its endpoints on the circle. So again, chords don't have any properties really to speak of yet, but we will see chords later on in some of the formulas and rules that we're going to come across with our circles. Okay. A term that we should be completely familiar with, and somebody mentioned it earlier in the class period, is the idea of a diameter. So I think everybody knows what a diameter is, even if they weren't able to, put a definition to it. But specifically, a diameter is a chord. It's got its endpoints on the circle. It just so happens that this chord passes through the center of the circle. So when you get a chord that passes through the center of a circle, then you have a diameter. And I think everybody knows what a diameter is and what it looks like. The only thing I warned you about, I reminded you yesterday, be very careful with diameters. Make sure that you actually have a line segment, a chord that does pass through the center of the circle before you call it a diameter. Okay. If a line segment appears to go through the center, that doesn't mean it actually does. Okay. You need good information to prove that it goes through the center. Okay. So once you know what your center point is, and you know that you have a chord that passes through it, then we don't call it just a chord, we call it a diameter. Next. Okay. While we're on the topic of diameters and terms that we know, here is a radius. A radius is a segment that has only one endpoint on the endpoint on the center and the other endpoint on the circle. By that definition, a radius is not a chord. Chords have to have both of their endpoints on the circle. Okay, radius has one endpoint on the circle, but the other endpoint stops at the center. Okay. Again, I expect that that is a definition that everybody knows, and we would be able to recognize it if we saw it in a figure. So there is not a whole lot of new vocabulary to be discovered yet on this page. The only real new information that I think we'd probably need to worry about, and it's not really new, just a refresher, is that, of course, there's a relationship between a diameter and a radius. And that relationship, obviously, is that a radius is going to measure exactly half of the length of a diameter, which is kind of obvious. Radius goes halfway across the circle, diameter goes all the way across. So it's pretty clear to see that your diameter is going to be twice as big as your radius. Okay, now getting into some more specifics. we are going to be seeing lots of instances where line segments or rays or lines are going to be intersecting our circles. Okay. Now there's different ways that our line segments and rays and lines can interact with the circles, different ways they can intersect. And depending on how they intersect a circle is going to change what type of a term, what type of vocabulary we call them. So pay special attention in this part. Okay. The first one we're going to look at is an instance where a line or a ray or a line segment are going to hit our circle, but they only hit it once. If a line were to intersect a circle only one time, that would be called, and the word is tangent. Now we've heard the word tangent this year before. Okay. Anybody recall where we talked about tangents? It was back before the Christmas break. We were working on trigonometry, did our SOHCAHTOA stuff, sine, cosine, and tangent. Okay. There's a relationship between the tangent function that you were working back then and the tangent a circle. Okay, but we're not going to explore that relationship or anything like that, but you should have at least gone, I've heard that word somewhere before. Okay, and when we say that a line ray or line segment is going to intersect our circle one time, this one location is what we refer to as a point of tangency. And like I said, we're not going to go deep into the relationships of what happens at this with a tangent or with the point of tangency, but do understand that if you go as far as pre-calculus at some point in time, you're going to spend a great deal of time working on different types of problems that are going to be associated with tangents and points of tangency. Okay. But back to the definition, when it said that we're only going to intersect a circle one time, and that location is going to be called a point of tangency, please understand that we are saying that there is a line or ray or line segment that when it says it intersects one time, it's not like it enters the circle and then stops before it comes out the other side. We're simply saying that this line or ray or line segment just kind of glances off of the circumference of the circle. It doesn't actually enter into the internal space of the circle. It just kind of hits, but it just barely nicks it on the way by. And by doing that, by just barely nicking it, then we end up with a tangent. That one spot where it hits, that is what we call our point of tangency. Okay, and there is a statement about that circle. Okay. A property that goes along with tangents is actually a very, very important one when you get to pre-calculus, as I said before. But the property is that tangents are always perpendicular to the radius of the circle. In pre-calculus, you'll be working with shapes that are not circles. Maybe they're just curves. Okay, and it'll be the same idea. You'll still get a perpendicular relationship. Okay, but again, for right now, we're just talking about circles. We don't have to understand all the pre-calculus stuff, but tangents are always going to be perpendicular to a radius of the circle. Okay, which is to say, again, there's that diagram from the last one. Wherever that where line AB made contact with the circle, which we call the point of tangency, if you connect a radius to the point of tangency, then there's going to be a rule right there. You're going to have a right angle. And as always is the case, anywhere right angles show up, you have the possibility of right triangles showing up. Then you get Pythagorean theorem, you get SOHCAHTOA. Okay, so you can kind of see where the math of tangents might start to come into play because of that right angle. Anywhere you have right angles, you're going to have right triangles. Okay. Now, there's a couple of different types of tangents, and I'm not really sure that we need to know these terms. but while we're here, we're going to go ahead and talk about it. I'd hate for them to question this on your end of year tests, and you didn't know just because I never bothered to tell you. Okay. It is possible that a single line or ray or line segment could be tangent to two circles at the same time. Okay. If a line is tangent to two circles, then we call it a common tangent. Okay. And this common tangent can do one of two things. It can either pass by two circles on the same side, kind of like it passes like, say, pass over the top of one and then pass over the top of another one, okay? Which is basically to say if it passes around the circles, that's what we call a common external tangent. The flip side of that is we have what's called a common internal tangent, and that's going to happen when the tangent actually passes between two circles. It makes contact with one on the way by, but then makes contact with another one kind of on the opposite side. And I'll show you a diagram here in a second, so that'll make sense. Okay, but common external tangents is if it kind of passes away, passes by the circles. Internal tangents is where it passes in the space between the two circles. Okay, and here are some examples of the differences between common external tangents and common internal tangents. We've got two circles, circle D and circle C. The green tangent on your screen, okay, line RQ is going to be a common external tangent because it does not get into the space directly between circle C and circle D. The red one, however, line SQ, is what we call an internal tangent because there is a space that is between circle C and circle D, and it passes between them. Now, for those of you that are auto mechanics and stuff like that, you've probably seen external tangents and internal tangents in the engine compartment of your vehicles. Okay, your belt runs around several pulleys. It goes around one direction on some of them, different directions on a different one. Okay, but basically your belt is acting like a tangent. Okay, sometimes it passes between stuff, sometimes it passes around stuff. Those are internal and external tangents. Okay, now that was all about tangents. Tangents only intersect circles one time. Okay, and they only intersect one time, like we said, because they do not enter into the internal space of the circle. Now we're going to look at what happens when lines, rays, and line segments do enter into the internal space. They're going to hit the circumference of the circle, they're going to come into the internal space of the circle, and then they will hit the circumference again on their way out of the circle. So if a line were to intersect a circle at 2 points, that line would be called, and it's called a secant of the circle. And secant is a word that we have not discussed. Okay, but actually back in the fall semester, we talked about the basic, or what are called the primary trigonometric functions, sine, cosine, and tangent. What we did not discuss, and we won't talk about it really any more than this moment right here, right now, there are also three what are called secondary trigonometric functions, which are secant, cosecant, and cotangent. Okay, so secant is one of the secondary trigonometric functions. Okay, we just haven't looked at it yet. You'll spend more time, for those of you that, again, if you end up going as far as pre-calculus, then you will work with the functions of the secondary functions like secant. And one of the basic parts of a secant is that a secant does contain a chord. Okay, so if you want a diagram, there would be a diagram showing a secant of a circle. Okay, you can very clearly see that line AB, okay, breaks through the perimeter or the circumference of the circle, enters into the internal space, then hits the circumference again and breaks through and goes out the other side. Okay, so that is a secant. And again, it does contain a chord. You can see the little line segment inside of the circle right in the middle of the secant. Okay. Okay, that is pretty much the additional vocabulary that we are going to need in order to be able to move forward. Okay, so I'm not going to give you an actual assignment. We didn't really learn anything new as far as any math skills or anything like that. What I would like you to do is when you come back tomorrow, I would like you to have all of this new vocabulary, including any old vocabulary like central angles and inscribed angles. I'd like you to have that stuff down, as well as if you're still having trouble with how central angles or inscribed angles worked or what their rules are, I'd like you to get that done as well. Okay, so your only assignment is to come back to class tomorrow fully prepared with all of the information that we have talked about for circles.